Welcome back to Dr. Fogg's TV.
Hey everyone, I remain your humble Dr. Fox. So today we're looking at chemistry, how to calculate relative molecular mass and percentage composition of each element. So I'm going to calculate relative molecular mass and percentage composition. So the first one I have is H2SO4, which is hydrogen tetraoxosulfate 6. So coming here, I have my solution. So when calculating relative molecular mass, it simply means that you are going to add mass numbers of the respective elements you have in the question. So all these are compound, which means that combination of elements which are chemically bound together are called compounds. So each of the elements, you are adding their mass numbers, which means that as a chemistry student, you should know some mass numbers of elements. For example now, hydrogen is 1, carbon is 12, nitrogen is 14, oxygen is 16, calcium is 40, potassium is 39, sodium is 23, chlorine is 35.5, and so on. So the first one here is H2SO4. So this is H2SO4. So to calculate relative molecular mass, hydrogen is 1. But because I have two atoms of hydrogen here, it becomes 1 times 2. Then plus sulfur is 32, then plus oxygen is 16. But because I have 4 atoms, here becomes 16 times 4. So here becomes 2 plus 32 plus 64. Here gives us 98 gram per mole. So this is the relative molecular mass of H2SO4. Now, to calculate the percentage composition of each element here, percentage composition of hydrogen is 2. It becomes 2 divided by the molecular mass, then multiplied by 100. So here I can say 2 here 1, 2 here gives 49. So percent of hydrogen becomes 100 divided by 49, which is 2.04%. And I move to sulfur. Percentage composition of sulfur. Sulfur is 32 divided by the molar mass, that's the total, which is 98, then multiplied by 100. So I can say 2 here will give me 16, 2 here will give me 49. So percentage composition of sulfur becomes 16 multiplied by 100 is 1600 divided by 49, that becomes 1600 divided by 49, that becomes 32.65%. Then we move on to oxygen. Percentage composition of oxygen. Oxygen is 64 because I have 4 moles there, 4 atoms. Here becomes 64 divided by 98 multiplied by 100. So percentage composition of oxygen becomes here 2 here will give me 32, 2 here will give me 49. So from here becomes 3200 divided by 49. So the percentage composition of oxygen becomes 3200 divided by 49. That becomes 65.31%. So that is question 1. So this is molecular mass of H2SO4, and this is the percentage composition of hydrogen, 2.04%. Sulfur is 32.65%. Oxygen is 65.31%. So we move to number 2. That is KClO3. So this is potassium trioxochlorate 5. Potassium trioxochlorate 5. So the first thing I do is to calculate the relative molecular mass of KClO3. So potassium is 39. Let me write KClO3. Potassium is 39 plus chlorine is 35.5 plus oxygen is 16 multiplied by 3 because I have 3 moles there. So KClO3 becomes 39 plus 35.5 plus 48. So KClO3 becomes 39 plus 35.5 plus 48. That is 122.5 gram per mole. So I will calculate the percentage composition of each element there. So the first one is potassium. Potassium is 39 divided by the total 122.5 multiplied by 100. So percent of potassium becomes 3,900. That is 39 multiplied by 100, which is 3,900 divided by 122.5. So percentage composition of potassium 3,900 divided by 122.5, that becomes 31.84%. So I calculate for chlorine, percentage composition of chlorine. Chlorine is 35.5 divided by the total, that is 122.5 multiplied by 100. Percentage composition of chlorine becomes 35.5 multiplied by 100 becomes 3,550 divided by 122.5. Percentage composition of chlorine 3,550 divided by 122.5. Here becomes 28.98%. So the last one is oxygen. Percentage composition of oxygen. Oxygen is 48 because it's 16 multiplied by 3, which is 48, divided by the total, which is 122.5 multiplied by 100. So percentage of oxygen, 48 multiplied by 100 is 4,800 divided by 122.5. Percentage of oxygen becomes 4,800 divided by 122.5. That is 39.18%. So that is number 2. So this is relative molecular mass of potassium trioxochlorate 5. There is the percentage composition of potassium, and this is chlorine, and this is oxygen. So very quickly move to number 3. So number 3 is PbNO3 2. This becomes lead 2 trioxonitrate 4. Lead 2 trioxonitrate 4. So for PbNO3 2, so here is PbNO3 2. Let me have it from here. Lead is 207 plus, I open my brackets, nitrogen is 14 plus oxygen is 16 times 3, then close bracket, everything multiplied by 2. Because this NO3 is in the bracket and they are all multiplied by 2, which means that lead is not part of the NO3, which is in bracket. So here becomes 207 plus, this is 14 plus 16 multiplied by 3 is 48 times 2, and this becomes 207 plus 14 plus 48, that should give us 62, multiplied by 2. Here becomes 207. 62 multiplied by 2, that is 124. So it becomes 207 plus 124, that becomes 331 grams per mole. Now, to calculate the percentage composition, I start with lead. Lead is Pb, which is 207, divided by the total 331 multiplied by 100. So percentage of lead becomes 20,700 divided by 331. That becomes 62.53%. So we go to percentage composition of nitrogen. Now, nitrogen is 14, but the 2 outside is affecting both nitrogen and oxygen, which means that this PbNO3 can also be written as PbN2O6, which means that here is 1 multiplied by 2, and here is 3 multiplied by 2. So nitrogen is 14 multiplied by 2, that is what? 28, divided by the total 331 times 100. So the percentage of nitrogen becomes 2,800 divided by 331. Percentage of nitrogen 2,800 divided by 331 becomes 8.46%. Then the last one is oxygen. Percentage of oxygen. Oxygen is 16 multiplied by 3 here, which is 48. Then 48 multiplied by 2, that is the value I'm using. Or I can as well say 16 multiplied by 6. We have the same value. So here becomes 96 divided by the total 331 times 100. So the percentage of oxygen becomes 9,600 divided by 331, that is 29.00%. So that is for lead 2 trioxonitrate 4, which can also be written as PbN2O6. So this is the relative molecular mass, this is the percentage composition of lead, and this is for nitrogen, and this is for oxygen. Now, we all know that percent is over 100, which means that when you add your answers, you add this with this and this, you must get 100%. Same thing applies to number 1 and number 2. So when you add your answers in percent, you must get the total percent, which is 100. So we move to number 4. Number 4, we have Na2CO3 dot 10 H2O. Now this compound is called sodium trioxocarbonate 4 decahydrate. The water is called the hydrate. Water is called hydrate. That's why it's sodium trioxocarbonate 4 decahydrate. Now why is it decahydrate? Because of the 10. Don't forget, in our mathematics, our 10-sided polygon is called decagon. And when we check our organic chemistry, our alkane, and alkyne series, we are made to understand that the 10th member of the family of alkane is decane. The one of alkane is decene. The one of alkyne is decyne. That's why it is decahydrate. Let's assume it is 5. It becomes pentahydrate. If it's 6, it becomes hexahydrate. If it's 7, it becomes heptahydrate. If it's 8, it becomes octahydrate. If it's 9, it becomes nonahydrate. Likewise 4, tetrahydrate. 3 is trihydrate. and 2 is dihydrate, and this one that is monohydrate. That's why we got what decahydrate form. And this is Na2CO3 dot H2SO4. Now this compound Na2CO3 is a salt, is also a base. Now when water is added to a salt, that water is called water of crystallization, which means that this salt Na2CO3 contains water of crystallization. And we also need to understand that in acid, base and salt, we have one characteristic of salt which says efflorescence, which is what ability for a salt to lose some or all of its water of crystallization. But at this moment, this compound I've written here still contains its water of crystallization. So I'll calculate. So my Na2CO3 dot 10H2O, sodium is 23 multiplied by 2 plus carbon is 12 plus oxygen 16 multiplied by 3. Now that dot does not mean times, it is still plus. So I open my bracket. Okay, I have 10 and I open the bracket. Hydrogen is 1 times 2 plus oxygen 16. The 10 in front is affecting both hydrogen and oxygen. That's why the 10 is here, and I have to open brackets for H2O, which is 1 times 2 then plus 16. So from here, 23 times 2 is 46 plus 12 plus 48 plus 10. Here is 1 times 2, 2 plus 16, that is 18. 1 multiplied by 2 is 2 plus 16, that is 18. So here is 46 plus 12 plus 48 plus 180. So my final answer becomes 46 plus 12 plus 48 plus 180. That is 286 grams per mole. So for the percentage composition, I'll start with sodium. Percentage composition of sodium. Sodium is 46 because I have 2 moles of sodium here. So here becomes 46 divided by the total 286 times 100. So I can say 2 here 23. 2 here will give me 143. So percentage of sodium becomes 23 multiplied by 100 is 2300 divided by 143. Percentage of sodium becomes 23 divided by 143. That gives me 16.08%. So I move to carbon. Percentage composition of carbon. For carbon, carbon is 12 divided by 286 times 100. So I can say 2 divided by 12, 2 divided by 2 is 6. Then 2 will give me 143. So percentage composition of carbon becomes 6 multiplied by 100 is 600 divided by 143. Percentage composition of carbon becomes 600 divided by 143. That is 4.19%. So I move to oxygen. Percentage composition of oxygen. Oxygen is 16 times 3, that is 48. That is 48 divided by the total, which is 286 multiplied by 100. So I can say 2 here 24, 2 here 143. So percentage of oxygen, 24 multiplied by 100 is 2400 divided by 143. Percentage of oxygen, 2400 divided by 143, that is 16.78%. So the last one is water. It's called water of crystallization. So I'll say percentage composition of water of crystallization is water is 18. Multiply by 10, 180. That is 180 divided by the total 286 times 100. So percentage of water becomes 2 here will give me 90. 2 here will give me 143. So 90 multiplied by 100 is 9,000 divided by 143. Percentage of water becomes 9,000 divided by 143. That is 62.94%. That is everything on sodium trioxocarbonate 4 decahydrate. So this is the relative molecular mass. This is the percentage composition of sodium. This is the percentage composition of carbon. This is for oxygen and this is for water. So when you add your respective percent, it will be equal to 100. So let's move to the last question, which is number 5. I have KMNO4. This is a purple liquid. It is called potassium tetraoxomanganate 7, also called potassium permanganate 7. So all those numbers I mentioned last, like now, here is tetraoxosulfate 6, here is potassium trioxochlorate 5, here is lead 2 trioxonitrate 4. So those numbers are gotten by calculating oxidation number. So very soon, I will also make sure that that also gets on air. So this is KMNO4. So for potassium, this is KMNO4. Potassium is 39. Mn is manganese, while Mg is magnesium. So here I'm working with Mn, which is manganese, and that is 54.9 plus oxygen 16 multiplied by 4. So here is 39 plus 54.9 plus 64. So here becomes 39 plus 54.9 plus 64. That becomes 157.9 gram per mole. That is relative molecular mass. So we calculate the percentage composition of potassium. So this is potassium, which is 39 divided by 157.9 multiplied by 100. So percentage of potassium, 39 multiplied by 100 is 3,900 divided by 157.9. So the percentage of potassium becomes 3,900 divided by 157.9. That is 24.69%. So for manganese, percent of manganese is 54.9 divided by the total 157.9 multiplied by 100. Percentage composition of manganese 54.9 times 100, that is 5,490 divided by 157.9. Percentage of manganese, so 5,490 divided by 157.9, that is 34.77%. So the last one is oxygen. Percentage of oxygen becomes, oxygen is 64 divided by 157.9 multiplied by 100. So percentage of oxygen, 64 multiplied by 100 is 6,400 divided by 157.9. So which means percentage of oxygen becomes 6,400 divided by 157.9. That is 40.53%. So that is all on relative molecular mass and percentage composition of elements in each compound. So here is KMNO4, which is potassium tetraoxomanganese 7 or potassium permanganate 7, and this is relative molecular mass. This is the percentage composition of potassium. This is one for manganese, and this is one for oxygen. So when you add the percent, everything will be equal to 100. So that is the end of this class. So you like, you view and subscribe to my YouTube channel. See you in the next video.